So we are inside the Fabric environment. Here we have a lookup activity followed by a copy activity and a notebook in our ingestion pipeline. Why is this the logical sequence? In this pipeline, each step serves a specific business purpose. The lookup step retrieves the last successful watermark. This tells the system that what we have already processed, so we don't reload unnecessary data. The copy activity then pulls only the new or changed records from the source, and that is where the efficiency comes in. We avoid full table scans and reduce load on both the systems. Finally, the notebook applies the business transformation. It cleans, it deduplicates, it validates, and prepares the data for analytics. It's the logical flow. It knows what to extract, it extracts it, and then turns it into business ready insight. But what is the specific purpose of the watermark? It acts like a bookmark. Instead of loading everything, we only load what is new. So this incremental logic will lower your costs. It gives faster refreshes and thereby increasing the decision velocity. So where does the watermark store and how does it update? We store the watermark in a dedicated Delta table inside the lakehouse. It becomes part of the data contract, the single source of truth for the ingestion progress. So in here, how does this pipeline address late arriving or out of order records? In to avoid the missing updates, we don't just rely on just the highest timestamp. We apply deduplication and validation in the notebook so that the system stays accurate even when the source system is not. Even if we needed historical reprocessing for a specific date range, we can allow the pipeline to accept override parameters. So there is an option that could temporarily ignore the stored watermark and process the range that we need. So this copy activity um, sources it often comes it has bottlenecks also, and those come from the source systems and large partition sizes, and sometimes it is optimized by enabling parallelism using partition queries and pulling only the required columns. So that is how we ensure fast and predictable ingestion. Is this pipeline scalable? Yes. Rather than building 50 pipelines, we parameterize one reusable ingestion template. There is a source name, there's a table name, and there is a watermark setting. This this system is an ingestion framework and not just a collection of pipelines. So before running, we do a lot of schema validation. We check for the null or missing values and duplicate detections. So bad records go into the quarantine zone and it is not part of the analytics. So even if the volume grows by 10 times, we can scale through a partitioned ingestion, vectorized operations, or we can optimize the delta files through compaction. So we can also use warehouse for high concurrency queries. So this architecture just grows elastically without a redesign. To to run this into an ingestion product rather than a one-off pipeline, we package the entire system as source the definitions, we have the patterns, we have the duplication logics within the notebook, and we have error handling templates, we have the standard schema mapping rules, and automated lineage tracking. So this allows the source table to onboard quickly without um, with minimal engineering effort. So all of this, the watermark logic, the incremental loading, the scaling, this unified architecture serves just one uh, purpose: to deliver real-time business outcomes. So in the next part, I will show you what this enables. It enables faster decisions and earlier warnings and fewer disruptions. So this is where the technology becomes impactful.